Hello, so now we're here. We're going to be discussing lesson 122, which is a pear deck, and it seems that people are very confused by this one. So I'm going to I decided to walk you through the pear deck rather than trying to do just a video of my side. So this is what you will see when you come in. So again, it's lesson 122, and we're talking about area and perimeter of unusual shapes. So we're going to build on our knowledge of geometric relationships and reinforce some algebraic skills that we hopefully gained in Math 1. And we're going to look at what happens as the pattern grows. So take a look at this, and I forgot to delete my response. I tried to make this video earlier, but look at this. I typed in my answer. C is the top is shorter than the bottom. And so there we are. No problem. All good. We're going to move on. Okay. So, because I look at this, it looks like a C, maybe a J, maybe what you see is what you should describe. So then this perimeter created graph and table and equation. So when we were talking about this in class, there were quite a number of people who were confused by let's get a color here. By this particular, what perimeter meant and how to see it. Because we can see the 6 squares there pretty straightforwardly, but the perimeter is the edge. So we're looking, and that's not very thick. I'm going to try in a different program too, so I'm just going to see if I can make it thicker. We want it medium, I think. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 around the edge, so 1 is 14. Now you can't write on this, so you're going to be typing. And so we know the first one, we go into typing, we just would type 14. And so then when we look at this, we're looking at what happens. So as we enlarge the figure, each white square became 4 squares, but the edge became 2. So the edge that was 1 before has now become 2. And so my edge is now 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 4, 6, 8. So 28. But I also noticed that 28, that this number doubled or that I added 14. Whichever way you want to think of that, both are correct. So it got bigger. I added 14. And so now I have 28. So what's going to happen the next time? So instead of having 1 along the edge like I did in the original, or 2 along the edge like I did in the second one, I now have 3. So I've gained another 14 squares because I've gained 1 more square over this one. And from the original, I've times it by 3. And so the next number is 56, excuse me. So I'm just going to go ahead and type that. Then fourth, there's different ways to get to the fourth figure. You can either think about adding. So we're adding 14 every time. Or we can look at what else is happening. But the adding 14 is reasonable. The other thing that's happening is I'm taking the number. So this was 56 and this is 70. I'm taking the number and 4, that's not fit. I went too fast. This is 42 and this is 56 and this is 70. Excuse me for mistyping that. Let's go fix that. I skipped over 42. Sorry about that. And so those are pretty straightforward. And again, you can either get there by adding 14 or by taking the number and timesing it by 14. And so there's a bunch of other numbers, and then we get to 20. And so 20 is 14. The fastest way is 14 times 20. And so I use Shift 8 to get that time sign there. Because I don't want to use X for times because X means something else in math now. So I'm going to use that asterisk-y thing, and I get 280. Okay, so there you go. There's the perimeter. Let's go and see what we have next. I'm going to clear. Here we go. Here we go. Next. So create a graph on Desmos, and I asked you to put your link in here. So we would jump over to desmos.com. Let's do that here. And we're going to make, we're going to put the table in here. So I'm going to add a table. And I'm going to put in the number 1, and that was 14, and 2 was 28, and 3 was 56, excuse me, 3 was 42, 4 was 56, 5 was 70, and then 20 was 280. So I don't see any of my dots on here. So again, I got the table by clicking on this plus sign and adding a table. Now I'm going to go ahead and move my face. And so we need to do a couple of things. You'll notice that this link hasn't changed at all, even though I've added stuff here. But if I log in with Google, then now if I click save, I'm going to get see how this has now changed, and I can actually send myself this link. You can't do that unless you've logged in. Okay, so anyway, I need to just make it so I can see. So I'm going to go ahead and I want to turn on projector mode personally, and I don't need any negative numbers. So I'm down here under x-axis. I'm going to change this to -1 so I can see the x-axis, and I need to go up to 20. So I'm going to go to 25 just to keep going. And then again, for the y-axis, I don't need any negative numbers. And I need to go all the way up to like 300. So 280, we'll go 300. And look, there's my dots. So once again, what I did there is I clicked on this wrench. I also came in, did all the stuff, right? So I clicked on the wrench right here. I've changed the x-axis and the y-axis. And I can change what I'm counting by too. That's what the step is. Like if I want to count by 5, right, and it'll count for me. So maybe this way I want to count by 10s, and so it'll try to do that. It's hard with this one because of how spread out everything is, but that's kind of the idea, okay? So that's more a problem for later. The step count is not really something we need to mess with. All right, so there I have all the dots. Kind of bring them all onto the screen that way. And it looks like they're in a straight line. And so I'm going to go ahead and click Save. And I'm going to click on this one right here, which says Share the Graph. And there's my link. I'm going to click Copy. Or you can also grab it right here and copy, but it's kind of nicer to do it from there. So I'm going to go back to the presentation and paste my answer in. Okay, and so now that would take me, when I come back and look at this, I can go see what you typed in. Okay, we're going to use decimals to help us make our equation on the next slide. All right, write a pattern equation for the pattern, record it here. So we're going to go back to decimal. Actually, we're going to see what we can do. We know y equals mx plus b. And so what's m and what's b? So figure 1 is not b. Figure 1 is 14. And then I did what to move to figure 2? And what did I do to move to figure 3? I added 14. 14 is the pattern, which means 14 is the slope, because it is the one that is consistent. So 14x. And then what about the starting value? So let's go back over here. Let's choose 1 because I don't know. So we'll just choose 1. And let's go over to decimals, and actually, you know what? I'm going to choose 10. And it doesn't matter. So again, I'm going to move my lovely face out of the way. So we have y equals 14x plus 10. You can see I'm off, because 1 you can't see very well, so because like 1 it doesn't look like it, but it is off. And 10 you can really tell it's off, because 0 goes right through them. Because if I follow this pattern where I add 14 every time, if I went back to 0, I would have nothing. And so it is 0. Okay, so I'm going back to my presentation. I don't want anything here. I can either leave it like this, or I can add 0. Okay, so that's up to you, but that's the idea. Okay, so that's what we're doing. So then we're going to play with area. So area is different, and we're going to start with area is how many squares are there. So I'm just going to count the squares. Really straightforward. I'm just going to count 1, 2, 3, 4, 5, 6. So my area is 6. Now what happens to my squares? It did not double, because if I just go 12. Let me just count 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I didn't get the whole thing. So it's not doubling like it did before when it went from 14 to 28. Because each of these single squares now became 4 squares. So the single square has become 4 squares. So this is 4, 8, 12, 16, 20, 24. So this is 24. And so what happens is when we're doing this, something different is happening that has really never happened before. I added a total of 18. Okay, so let's see what happens here. Now my square, instead of being 1, is 9. So it was 1, 4, 9. 1, 4, 9. Interesting. 1, 4, 9. That's very interesting. And I have 6 nines. 9, 18, 27, 36, 45, 54. So this is 54. And now I've added 30. So I added 18, then I added 30. This is not a line. And so it must be doing something else, something new, something different. Okay? And so I wonder what it is. So we're just going to go ahead and fill out our table. So let's go ahead and do that. And so we've got 6, 24, 54. I wonder what will happen with 4, the fourth figure. So I went 1, 4, and 9. Figure 4. Figure 3 is 9. Figure 2 is 4. Figure 1 is 1. Maybe 16? Because 1, 4, 9, 16. Because 2 times 2, 3 times 3. And if you look at the square, that makes sense, right? The square is going to be 4 by 4 on the next one. If I was going to draw it, I would get that for each square, right? I mean, it's terribly drawn, but I would get 16. And so it's going to be 16 times 6, which is 96. And the next number is 150. That's going to be 25 times 6. And so my last number is going to be 20. Oh, I'm going to times by 6. I feel like that's going to happen. And then I'm going to have 20. So it's going to be a big giant square. And there's going to be 20 squares this way and 20 squares that way. So there's going to be 400 squares because that's 20 times 20. So 20. And this is squared, by the way. So 20 squared, which is equal to 6 times 400, which is equal to 2,400. So that's a lot of squares. See why I don't want to draw that? It's a lot of squares. So that's the idea. Does it make sense? I hope so. We're going to be playing with this pattern more as the year develops, okay? This pattern is very different. Let's go ahead and see what's next. So create a table, graph, and equation. We're going to go to Desmos and create a graph. So I'm just going to jump over here. I'm actually going to go ahead and turn these two off. So notice I've just kind of clicked on it and turned them off. I'm going to add a table, new table, and it was 1, 6, 2, 24, yes, 3, 54, 4, 96, 5, 150. Now this is curving. So our natural instinct is to say this is exponential because exponentials were curves and lines were lines. And that's what we knew last year. That's all we did in Math 2. Math 1 was curves and lines. And so if it was a curve, it was exponential. If it was a line, it wasn't. This is not exponential. It's not. It's also not a line. It's something new. This is a brand new pattern. Okay? This is a brand spanking new pattern. Okay? So I'm going to go ahead and save this again. I might even give it a name, like call it 2 wait, excuse me, 1, 2, 2, and I see I've done this one a couple of times. Let's call it video. Okay, so I have them both, and then I'm going to do another equation. And so it's the side times the side. Weird. See how on this side, both sides of this curve go up? Pretty crazy, huh? We haven't seen this before. This is a new pattern. So x times x is x squared. So another way to write that is y equals 6x, well, not 6 squared, 6x squared. There you go. And there it is. Okay, same thing. Those two are the same. Okay, I'm going to hit save again. I'm going to grab this and share and copy and come back over here and paste my link there. There we go. And so there we are. And then write an equation. So we did that in Desmos. And if you recall, we had y equals 6xx because we used x twice. Or y equals 6x squared. And if you don't understand this one yet, that's cool, because we'll be spending a lot of time with this, and by the end of the year, I hope you'll understand it. That's it. So that's the end of what we did in class. Now, the goal here is to pick another rug from the original designs. So, if you go to back to the classroom, in this assignment, it says, complete one additional rug problem except for the one we did in class. Attach your work here, PDF, or complete it on the Pear Deck. I'm going to complete on the Pear Deck. So these are my rug choices. So I can either do this upside down staircase. C is the one we did, so I can't do that. I can do a U. Or I can do a regular staircase. I can do an L. Or I can do this U with a middle in it. I'm going to do the U. Seems like a good choice. And so on the screen, I'm supposed to draw it. So I already know what it looks like. Sketch the original design of whatever rug I choose. So I'm going to go ahead and draw it. I choose this rug. Looks like that. Okay. That's all we're doing on this side is the rug I choose. All right. Create, and then we're going to do the same things. So I need to go to Desmos. You can use the same one. It doesn't matter. You can, and just change everything to the new patterns, or you can start over. That's totally up to you. So I'm going to just change it because that seems easier. So I'm going to turn this one on and this one off. Okay. So I'm going to go back and look at my pattern. And so it's the perimeter is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I think it's 16. 2, 5 on the inside part, 6, 7, plus 9, yeah, it's 7 and 9 is 16, so this is 16. So going back to this, my table, give me 16, and I'm going to times by 2, 32, times by 2, no, add 16, or times by 3, 16 times 3 is 48. 4 times 16. I don't know. I'm feeling 64. I knew that. 5 times 16 is 80. And then 16 times 20 is 320. So there's my table. I'm going to create a graph on here on Desmos. I'm going to put those numbers in. So 16, 32, 48, 64, 8320. Okay, and that last dot's under my face. Actually, that last dot is up there, not under my face. Okay, and so since it was 16, my pattern becomes, instead of 14, 16x. Check and make sure. Yep, go through all the numbers. Yay. And so then I'm going to write my equation equals 16x, and I'm going to grab the link. And I don't know if you're noticing the link is changing just a little bit every time. Okay, and there we go. And then the next slide is all about area. Same pattern, but now about area. So when I look at that U shape, it has 1, 2, 3, 7 squares in it. So it goes 7. Then it's 7 times 4 is 28. 7 times 9 is 63. 7 times 16. $112, $175, $7 times 20 times 20, which is equal to 7 times 400, which is equal to 11200. Nope, 280. Do that. Okay, so there's that. Write an equation for the pattern and graph it on Desmos. So I'm going to go back over here to Desmos. Let's scroll down here. I'm going to change that to 7. And then $28, $63. Turn that on, turn this off. Okay, turn this off. Turn that off. Okay. 796. It's not 96, it's 112. And 175. And then instead of 6 right here, we're going to have 7. There you go. That funny U shape. Let's see what we got. So back I go. We're going to type in y equals 7xx or 7x squared. Okay, and I still need my Desmos link. And so Desmos link right here. Copy. And your Desmos link should be different than mine. And that's it. I hope you have a great time with this activity. Good luck.